Okay, so hopefully we've seen that it's useful to have a product set to 0. However, let's try to look at a specific situation where something is maybe not set to 0. Let's look at this equation. So we're told that 4 minus x squared is equal to 0. This is clearly not a product. This is a minus sign. So I want to solve this equation. Well, what could I do? It's not a product right now, but maybe I could write it like a product. Now, in the previous sections, we saw that if we have, say, a product of two binomials, one with a minus and one with a plus, we end up with a difference of squares. A minus b times a plus b is equal to this. Why is that? Well, because we'll get a minus ba and a plus ba, and minus ba plus ba cancel each other out. Some of you might have an issue with the fact that one of these is an ab and one of these is a ba, but throughout everything in this class, a times b is going to be equal to b times a, because of the commutative property. There are other classes which are very interesting where this does not hold, but throughout this class, every single thing we're going to do, a times b is equal to b times a. So the point is we have this identity. And this identity works in both directions. If I have a difference of squares, like 4 and x squared, 4 is the square of 2, x squared is the square of x, what I can do is I can use this identity and go from here to here. Here, the a would be 2, and the b would be x. So I have 2 minus x times 2 plus x equals 0. Now, at this point, I now have a product equal to 0. And what do I know? I know if I have a product equal to 0, then one of the two must be 0. So we either have 2 minus x equals 0 or 2 plus x equals 0. Well, if 2 minus x equals 0, I get 2 equals x. And if 2 plus x equals 0, I get 2, well, let's move the 2 over instead. So I save one single line. So either way, I get x equals 2 or x equals minus 2. These are the two solutions to our original equation. So, two solutions. And of course, if you don't believe me or you're not sure, at any point when you're told that something's a solution to an equation, you can just check by plugging it in. If I were to take 4 minus 2 squared, I get 4 minus 4, which is 0. And if I were to take 4 minus 2 squared, I would also get 4 minus 4, which is 0. So I've verified that both of these are, in fact, solutions. And we know these are the only solutions. Because remember, the only way a product can be 0 is if one of these two things is 0. So we've done a lot with this one equation using that one idea about what happens when a product is 0. Now, what was the issue? Well, the issue here might be that maybe you wouldn't think to use this. Maybe you didn't remember this rule, or hopefully you now know that when a product is 0, things work out nicely. So what we want to do is we want to develop a collection of techniques that allow us to write something as a product. Because once something is written as a product, if one side is 0 and we're setting that product to 0, as you can see, we can get pretty far quite easily. And that's what we're going to be doing in this section.